In this video, we're going to continue our discussion with functions and using function notation. So a function may be defined as an equation in two variables. This equation, y equal to 2x minus 6, is an equation y in terms of x. And we know we can write it as x comma y, where x is the domain in this case and y is the range. Well, we can also write this equation as a function in function notation. F of x is equal to 2x minus 6. Again, x is the domain, and because there's no y here, f of x is represented by the range here. Okay? So f of x reads a function in terms of x, or we can abbreviate that f of x. So, given a function in terms of x is equal to 3x squared plus x minus 1, we want to evaluate the following. So, let's do a quick review with being able to evaluate functions at numerical values. So let's take a look at f of negative 4. Well, f of negative 4, okay. Now, every time I see an x, I'm going to replace it, in this case, with negative 4. So I'm going to do it in a different color. And we just evaluate the right-hand side using order of operations. Negative 4 squared is 16, times 3 is 48, minus 4 plus 1. So we know 48 minus 4 is 44, plus 1 is 45. So f of negative 4 is equal to 45. Now, I can write this as an ordered pair, negative 4, which is the domain in this case, and the range that comes out of this is 45. Now, I want to take a look at f of x plus h. Well, so, same deal here, f of x plus h. Every time I see an x, I'm going to replace it with x plus h. Okay, so I'll do that in a different color. Now, again, we're going to do order of operations. Now, above here, I'll do x plus h squared. Remember, that's x plus h times x plus h. So we know what? X squared plus xh plus another xh plus h squared. So we have x squared. Now we have an xh plus an xh. That's 2 xh's plus h squared. So we'll put that below. Now I'm going to distribute 3. Now, notice there are no like terms that I can combine here. Here's f of x plus h. Now, you could write this as an ordered pair. You don't have to. I will show once. Again, the domain in this case was x plus h, and my range is this very long polynomial. So it really depends on what x is and what h is in order to figure out specific values for this. Now, I will not expect you to write the domain and the range as an ordered pair for these types of problems, but for part A, you should be able to do that. Okay, so now let's scroll down to part C. We have f of x plus h minus f of x. Now, this looks complicated, but it is not. Only for the fact of we already did f of x plus h in part B. So, in blue, I will put what f of x plus h was thanks to the previous problem. That was 3x squared plus 6xh plus 3h squared plus x plus h minus 1, put that in parentheses, minus f of x. Well, we already know what f of x is thanks to the original problem here. That's 3x squared plus x minus 1. Now, for this next step, I will distribute the negative, and I'm going to drop the parentheses. And we're going to distribute the negative to every single term. Okay. Now, what ends up happening here? Terms subtract out. Please don't use canceling. I do not like the word canceling because I don't know what that means. But we are subtracting out terms. And what are we left with? 6xh plus 3h squared plus h. So, in other words, f of x plus h minus f of x is this trinomial. Now, notice what all three of these terms have in common. They all have an h. This will be used later on in this chapter. So the last thing I would like to do in this video is I'm going to use this graph to answer questions. Okay. We talked about earlier that we can graph functions on a coordinate plane. So we know y is equal to f of x here. I want to answer these questions. So part A asks for f of negative 3. Now remember, the negative 3 is in the domain. So let's go to negative 3. Well, negative 3 in the domain gets me to this spot here. So what range value goes with x equal to negative 3? Well, that's negative 1. So I would write f of negative 3 is equal to negative 1. When the domain is negative 3, the range value in this case is negative 1. Part B is asking for f of 2. But it's really asking me is when the domain is 2, what is the range value? So let's take a look at the graph. X equal to 2. That's this closed circle there. Okay. So again, when the domain is 2, what is the range? Well, the range is negative 4. Let's go to part C then. Determine all x values such that f of x is equal to 1. Now this time around they're saying when the range, or when y is 1, what is x? So I can draw this very quickly. When y is 1, looks like we have a point about right here. And that looks to be like about, I'd say about 3.5. So x is equal to negative 3 and 1/2. Now, part D says what all x values such that f of x is equal to negative 4. Well, again, it's asked me when the range is negative 4, what domain values make this a true statement. So I'm going to draw negative 4 here. Now notice it's touching it twice. Well, what domain values have a range value of negative 4? X equal to negative 2 and x equal to 2. So in this particular case, I have two solutions. Make sure that you can identify all the solutions. Okay, part E is to determine all intercepts. Okay, let's start with the x-intercepts. Remember, x-intercept is when the range is 0. Well, that happens at 0. And looks like about x is equal to negative 3 and 1/4. If I ask you to write them as ordered pairs, I can write it as 0, 0, and negative 3 and 1/4, comma 0. The y-intercept. Okay. Now remember the y-intercept. This is when x is equal to 0. Okay. So when does that happen? Well, the only time that happens on the graph, again, is when x is equal to 0. So notice the y-intercept I can write as an ordered pair 0, 0. Write the domain and range of the relation in interval notation. Okay, let's start with the domain. I'm going to write this down, and then we're going to go back up and take a look at the graph again. All right, so we start with negative infinity. We go all the way down, and then we come back up. and then we go all the way to the right. The only hole that is for the domain is at x equal to 2, but we already know that's covered because when x is 2, the range is going to be negative 4. So the domain in this case is going to be negative infinity to positive infinity. Okay, let's write the range then. Okay, so I'll write the word range, and then we're going to go back up again. The only thing we need to be concerned about is how low does it go? Well, you notice it doesn't go any lower than negative 4. There's no arrows that go down. So we know negative 4 is included, so we know that's going to be a bracket. Now, the only other hole we have to worry about is that hole where the range value is 2. But if I go all the way across on the graph, there is a spot where y is equal to 2. In fact, this entire gray part here is 2. So let's go down. Again, we know it starts with negative 4. And because it's a closed circle there, that's included and goes all the way up to infinity. So the last part is this relation a function? Well, let's go back up. Okay. Again, it would tell me every single domain value goes to exactly one range value. We know with the vertical line test that would work. The only concern some students may have is this vertical line at x equal to 2. Well, because that is an open circle, that's not part of the graph. So how many times is it touching the graph in blue? The answer is 1. Every vertical line that I draw there, it's only going to touch it once. So is it a function? Yes. And again, I'll write the definition of a function. Since every value in the domain maps to exactly one value in the range. Again, some students will say it passes the vertical line test. Just make sure you understand what that means.